starting Unit 5. And before we start Unit 5, I want to hand out the notes. To be doing a PowerPoint eventually up on the screen. Here it is. The airplane's been a little funky lately, so that's always fun. Okay, so a couple of things before we get started in Unit 5. I'll doing really well keeping up. So some excellent college skills on working independently. Let's keep up the good work. I'm going to draw your attention over to the wall that is where the door is. Okay. So you've got this, which is super small to see, but it's going to be handed out in your note packet. We're going to talk about that in a second. We also remember our limit flow chart. Okay, so at the end of the last unit, we learned something called multi-tiles. So here's the big reveal. Multi-tiles is just another branch on the limit flow chart. Okay, for indeterminate forms. Remember we would go, factor stuff and look at conjugates, a little bit trig identities. But that is a ton more cumbersome than just differentiating the top and differentiating the bottom. Okay. So that multi-tiles literally just shows up as another branch on the limit flow chart. Why couldn't we do that in Unit 1? Exactly. We didn't know how to take derivatives. So we couldn't teach it to you in Unit 1. We had to wait till you learned enough differentiation to be able to differentiate. So we had to learn the chain rules and all that other stuff. Does that make sense? Can you hear me okay at home? Should have checked a little earlier. Uh-oh, we all sleeping at home still?
Can hear you.
Oh, thank you. So, all right, so I am handing out the packet that people got yesterday. And if there's anybody who doesn't have the packet, hopefully you all do. We're doing the first day of notes. So if you just go to print it out on your own instead. So I just kind of made anybody do that. Okay, so if you notice on the notes that if you've got a schedule here, the schedule's short only because I'm only about a week ahead of the notes from you. So I'm trying to assemble those a little more friendly during our COVID time. So I will update the schedule when we get more stuff to the packet. But then if you open up the schedule on that first page, you'll see all of those graphs and those functions. And that's what's on the wall next to the limit flow chart. Too small to see even if it's in the classroom. So this unit is analytical applications of derivatives. Basically, we're really looking at shapes and graphs and how we can determine shapes and graphs by looking at derivatives and higher order derivatives. We already know that the first derivative tells us the slope of the curve. So it can tell us things like, is the curve increasing? Is the curve decreasing? And just by looking at the sign of the derivative. So we're going to start looking at that, those concepts. Okay. So these are shapes you should be familiar with. You should know what x squared looks like. You should know what e to the x looks like, and natural laws of x. Okay. And so I have them in the class, and then we have a quick reference sheet. Okay. So I still have a good number of people who still need notes. I always print out a couple more, but I'm probably missing about 5 of you. So this is particularly to people at home. If you need me to get notes to you, let me know if you don't already have them. Okay. So the first thing we're going to do in unit in Unit 5 is talk about this mean value theorem. And you took the notes on the mean value theorem. And so let's just kind of wrap up what that means. Okay, we have three big theorems for differentiation in calculus. Our first one was the intermediate value theorem. And that was like if we have two y values that correspond to two x values, then if we pick something in the middle of the y values, it's got to go to the middle of the x values. Right? Intermediate means in the middle or in between. The mean value theorem is today. Okay, and it literally says that if I have a function that's continuous and differentiable, it's got to be continuous over the closed interval. We got to have endpoints, and we can't have any discontinuities inside. It's got to be differentiable on the interior, so we can draw a tangent line. Then we know that the average rate of change, the algebra slope, and when we calculate that, we can find at least one point where the instantaneous rate of change is the same. Okay, so this is the second of the big three theorems. These theorems focus on a hypothesis that has to be true in order to use the conclusion. Okay, so the hypothesis for the mean value theorem is continuous on the closed interval, differentiable on the open. Okay, so no holes, no asymptotes, no cusps, no corners, none of that stuff can be there. If the hypothesis is false, then the conclusion doesn't have to be true or false. Where if the hypothesis is false, we pitch the whole thing. May or may not be true. Can't justify anything. Justifying using the mean value theorem involves two explicit requirements. Verifying the hypothesis. So verifying that this is either true or false. And then drawing the appropriate conclusion. So if this is true, then we can go on and do those calculations and find those points. If this is not true, then we can't do anything. Does that make sense? That's what the justification involves. Any questions so far? Okay, so a lot of times it comes down to looking for key information. Like, am I reading a problem and it's not saying that something's continuous? And I got to throw out the mean value here. Okay. And then, or it boils down to doing the calculations, finding that average rate of change, that algebra slope, setting it equal to the derivative and solving. Okay, so those are the types of problems you're going to see. So when can we apply the mean value theorem? What's my two criteria? Yep, continuous on the closed interval, differentiable on the open. Okay. And then if it can be applied, if we have continuous on the closed and differentiable on the open, then we can calculate the algebra slope and set it equal to the derivative. And that's what that mean value theorem says. So you've got two kind of activities. If you get into Blackboard, I have a mean value theorem matching game where it gives you a function and then a description, and you got to match them together. And then if you log into College Board, there's guided practice. These I would typically print out for you. But instead, I'm just going to direct you to the College Board site so that you can take them. It's a little more interactive. And then once you're done with that, you can go ahead and work on the first con homework, which is these two. Ironically, the answers for the topic questions are all C. Just happen to be that way. But I also have solutions to the topic questions right in College Board, or right in Blackboard, a solution set in case you want to look at the solution. So at this point, I'm going to cut my talking time and let you work on that guided practice and that matching game, and ask me any questions that you might have. So if you're at home, you can go ahead and get into your pods and work as a group. I'll stay and hang out here in space in case you got questions. I'm just going to